With the ever-increasing demand for faster, quieter, more fuel-efficient, and more versatile aircraft, NASA researchers need to develop advanced technologies in aircraft propulsion systems. NASA needs a reliable and efficient ground facility to perform measurements that are often difficult and very expensive to do on an aircraft in flight. One such facility is NASA Lewis Research Center's Aeroacoustic Propulsion Laboratory, which has been operational since 1985. The Aeroacoustic Propulsion Laboratory is an acoustically treated geodesic dome. This unique facility is 130 feet in diameter by 65 feet high. The layered aluminum and fiberglass construction of the dome and the 2-foot-thick sound-absorbing fiberglass wedges on the inside wall and floor provide an echo-free environment for testing and for protecting NASA's neighboring communities from the testing noise. The dome houses 3 test rigs that share a common need for the aeroacoustic characteristics of the facility. The first test rig is the Nozzle Acoustic Test Rig. This rig simulates the forward flight around a model of a jet engine, much like a wind tunnel. However, the Nozzle Acoustic Test Rig is an open jet, so the sound field of the model is measured without the interfering effects of tunnel walls. The test section, located at the mouth of the free jet, is 53 inches in diameter and simulates forward flight up to 3/10 Mach, or about 220 miles per hour. Advanced concept nozzles are mounted on an engine simulator rig, such as the high-flow jet rig shown here. High-temperature, high-pressure air flows to the nozzle, just as it would from a high-thrust aircraft engine. The model and rig are heavily instrumented to measure pressures, temperatures, thrust, and noise of the nozzle. 2 microphone arrays simultaneously measure the jet noise produced by the model. The arrays are located on 50-foot arcs centered on the model, one overhead and one to the side. By measuring the sound field over different angles, researchers can reproduce the sound that would be heard by a single observer as an aircraft passes by. Because the nozzle models are smaller than a real nozzle, the sound is higher pitched. Acoustic measurements are made at frequencies well above those heard even by dogs. The Traverse Exhaust Plume Survey Rake is used to measure steady total temperature, total pressure, and static pressure in a nozzle flow. A large laser Doppler velocimetry system acquires unsteady velocity in multiple directions in one of the largest installations of its kind. Between the different instrumentation systems, researchers measure the thrust, noise, and flow fields of different nozzle concepts, providing a complete picture of their performance and showing the way for future improvements. The second test rig is the Active Noise Control Fan. Here, researchers investigate using noise to cancel noise in the fan portion of aircraft engines. The 4-foot diameter fan is precisely driven by a 125 horsepower electric motor. By special design, the fan can be run without internal support struts, providing ultimately quiet fan flow as a baseline. A rotating rake of microphones in both inlet and exhaust measure the complicated acoustics modes of the fan duct and the effectiveness of the control methods being investigated. The rig can be moved adjacent to the nozzle acoustic test rig to simulate flying the fan past an observer. The third test rig is the Powered Lift Rig. This facility supports research on supersonic short takeoff and vertical landing research. These advanced aircraft nozzles require the rig to run full-scale models weighing up to 40,000 pounds and generating up to 60,000 pounds of thrust. The triangular-shaped thrust frame measures force in all 3 directions and rotation along all 3 axes. The rig's thrust balance system, a triangular frame 30 feet on each side, is mounted on 3 concrete pedestals standing 15 feet off the floor. The rig can test full-scale components, scale models, and full-scale engines. Its 6-component multi-axis thrust balance system can simultaneously measure thrust levels up to 60,000 pounds vertically, 25,000 pounds axially, and 10,000 pounds laterally. Ambient or heated combustion air up to 1200 degrees Fahrenheit and 150 psi is supplied to the rig from Lewis Research Center's Central Air Facility. The control room of the Aeroacoustic Propulsion Lab utilizes state-of-the-art high-speed computers to collect and store the dynamic and acoustic data of the 3 rigs. It utilizes graphical operator interfaces with programmable logic controllers and also offers remote access control room capabilities. The facility has provided NASA and the industry with valuable research leading to enhancements in aircraft engine designs needed to comply with increasing requirements to reduce jet engine noise. The quiet and efficient transportation technology of tomorrow begins with testing today at the Aeroacoustics Propulsion Lab at the NASA Lewis Research Center in Cleveland, Ohio.